Okay, continuing with section 6.3 for MAC 1114. I was just at the end of problem number 16 when the video cut off, so I had gotten to the point where I had explained that the radius in this unit circle is 1. We were at a quadrantal position, in other words, right at 0 degrees, same thing as 24 pi. And when I went to go do sine at that location, I took out the definition as I always do, y over r. Y value is 0. R value is 1. 0 over anything is 0. That's the answer to that one. Then in problem 17, same thing. If you want to, you can leave it as a fraction and just rotate to 13/4. You would have to, think about it as a mixed number if you're going to do that. So you would go 4 times 3. 4 would go in there. 4 times 3 is 12. Probably easier for you to just do it in degrees. So it would be 3 1/4. See, that's the same thing as 13 over 4. 3 times 4 is 12 plus 1 is 13. So you would go around 3 pi and then an additional fourth. And you're probably still going to be thinking about it in degrees, so you might want to just put 180 in here and think about it in degrees. Okay, when you go 3 pi, it's 1 pi, 2 pi, 3 pi, and then you would go an additional fourth. Each of these quadrants is a half. See, like that's 1/2. This is a whole pi. This is a 3/2 pi. So it's probably harder for you to think of it in fractions. But if you went to 3 pi, you'd be over here. Because again, 1 pi, 2 pi, 3 pi. And then if you had to go an additional fourth, that would be right in this quadrant right here. Come up to make a right triangle. That additional 1/4 pi, that's the same thing as 1/4 pi is 180 divided by 4, which is an additional 45 degrees. So this extra that you went after rotating to 1 pi, 2 pi, rotating to 3 pi, there's your extra 1/4, which is 45 degrees. Therefore, this is 45 degrees. Therefore, you have equal legs. However, now you're in a quadrant where things start to be negative. And in this quadrant, x's, which is represented by this horizontal leg right here, x's are negative. So don't forget to put that little negative there. In this quadrant where this triangle is, y's are also negative. So don't forget to put that negative right there. And then go ahead and do whatever they've asked you to do. So they want you to do tan. That would be your y value over your x value. Remember, this represents the y, the leg that runs up and down. This represents the x. So I don't know if I'd bother writing the fraction. You know that any number over that same exact number is going to be 1. So here's your y over your x. Even the negatives are going to cancel. This answer ends up being 1. Moving to number 18. Sine and cosine are given. Find the exact value of each of the 4 remaining trig functions. So what you could do is build a triangle off of this and then get the remaining trig values. So here we go. Number 18. Notice here comes your all students take calculus. Notice that or you can think of it like this. The sine is synonymous to the y value. The cosine is synonymous to the x value, or you may use all students take calculus. Okay, this time I'm just going to think about it in the easiest way possible. You want to be where y's are positive. You can either be here or here. But if you additionally need to be where the x's are positive, then you're going to have to be right there. Okay, so that means when I say you need to be here, I mean your triangle that you're going to be drawing. Now, they didn't give you any angles, no angles this time. They just bare theta, but they did give us a different way to figure out where our triangle is rather than rotating there. So, being in a quadrant where sine is negative, as they've given you right here, but where cosine is positive, would put us, what did I just do? Yep, messed up. All right, let me fix this. Okay, so where sine is negative, I don't know if I saw that or not. Yeah, I think I was treating this as though sine was negative. Okay, so I have to draw this again. Good thing I caught it before I finished. Okay, so let's start over again. I wanted to be where sine is negative. Sine is the y value, so that can only be here or here. Sorry about that. And then I wanted to be where cosine is positive. Cosine's like the x value. X's are positive over here. So this quadrant would suffice for both conditions. It would pass both conditions. So this is where I wanted to draw my triangle. So in other words, your rotating arm or hypotenuse is in the triangle that satisfies both conditions. And from the edge of that rotating arm, go up to the x-axis. And then we're going to start to put our numbers on this triangle. All our calculations will be done right from here. So let's see. How is sine defined? Y over R. So we're going to put this in the Y position. The vertical leg represents the Y. And the R value is the hypotenuse. So you're not inside of a unit circle. You can tell because the radius is not 1. Okay, then the cosine is defined as x over r. So they're telling you the x value is 7. R value is 25, which we already knew. Okay, so now I have my triangle, and I can answer cosecant, secant, tan, and cotan just by knowing the definition. So cosecant's related to sine, which is y over r. So cosecant, all you have to do for cosecant is to flip this over. You get 25 over 24. Flipping over does not mean you get rid of the negative. Okay, the secant graph has to do, the secant value, has to do with the cosine value. So you could just flip that over. And you'll have the secant value. So those come directly from what you were given in the directions, whereas you're going to have to look at the diagram you've created to get tan and cotan. So when you look at the diagram, there's nothing here that we can flip over that'll give us tan. So we come over here, we look at the picture. Tan is defined as y over x. So the y value is negative 24. And the x value is 7. But then you can take that, the one value that you had to get from this triangle, and therefore it had to be developed, is you can flip this over to get the cotan value. So flipping that over and then put the negative wherever you want, top or bottom. It's typically given in the top. And that completes number 18. Okay, let me see how many more there are here. Let's do number 19 now. Number 19. Let's see. So sine and cosine are given. Same thing. You're going to figure out first what quadrant you're in, and then you're going to try and find all the rest of the answers. So just like in the other problem that I just did, number 18, these two you could get just by looking at the values they gave you. So you're going to go sine and cosine or sine and cosecant are reciprocals of each other. So just flip over this sine value and you'll have the cosecant. Secant is the reciprocal of cosine. So flip that over and you will partially have the answer because it's just not simplified. You'll have to rationalize it by multiplying the bottom by square root of 195. And the top by square root of 195. So this will be 14 times the square root of 195 over 195. Okay, you should see if you can break down that 195 to see if possibly you could take a partial square root. So I'll just go 195 divided by 5, and I get 39. 39 is a prime number. or not, it's not a prime number, but when you break it down, it's 13 times 3. And both of those factors are prime numbers. There's no square root of them. So breaking down the 195 did not produce any numbers. Only 5 and 39 go into it that you can actually take the square root of. So you're going to report that answer as is. Okay, so let's go to, so that's a final answer for that. That's the answer for that. Now we can't go any further unless we do what we did right up here. We have to figure out where to rotate to based on sine being a positive number and cosine being a positive number. A place where all trig functions are positive would be in the first quadrant. So both sine and cosine are positive there. So we can just go right there and create our picture. So sine again is y over r, and cosine is x over r. So we know that our r value is 14, our y value is 1, and our x value is square root of 195. Okay, as we continue with this problem, let me get another pencil to write with. Okay, so now looking for the tan. Tan is defined as y over x. So you can do 1 over square root of 195 and then simplify it. So square root of 195 over 195. Okay, that's the third answer. And then cotangent is just going to be the tangent answer flipped over. You might want to flip this over right here, this thing that you had, this value that you had before you rationalized it, because that way you won't have to rationalize again. So flip this over and it would be square root of 195 over 1. Okay, that takes you all the way through number 19. And if there's anything significantly different here, I'll do it. Let's see, find the exact value of the remaining trig functions, not really different. They're telling you where to rotate in a different way. I mean, they're actually making it easier for you in this problem. And let's see, what else do we have in 21? So all that's different in these two problems in 20 and 21, so I'll just do one of them. I'm not going to do both of them, is that they're telling you where to rotate in a more simplistic way than what they did for numbers 19, for numbers 18 and 19, where you have to really think about the sign of both of them. Here they're just flat out telling you go to quadrant 3. Here they're just flat out telling you what quadrant to go to. Make yourself land between 270 and 360. I'll do this one. Go as far as I can before my time runs out, and I'll let you finish the rest. So this is 270 because this is 180. This is 90. This is 360. So if you're between 270 and 360, you're just simply right there. Go up to the x-axis and make your right triangle. Then you can put the numbers on like I have been in the other problems. Cosine has a definition. That's x over r. You've been given the x value of 24, r value 25, and whenever you have two sides in a triangle where the third one's missing, you can use, that's what Pythagorean theorem's for. So it goes hypotenuse squared. The hypotenuse always has to be by itself in the Pythagorean theorem. And then the other two pieces are the legs. So 24 squared plus y squared. The leg that runs up and down is the y value. Don't forget it's going to be negative. Okay, so then this would be 625. This would be 576. You're looking for y squared. You'd have to subtract the 576 from both sides. You'd end up with y squared is equal to, and I'm going to try and find this value, but I'm going to let you find the rest of the values yourself. So 625 minus 576 is 49. Then take the square root of both of these and you'll have y is equal